Let's focus on some of the properties of the wave, the period and the velocity. The period is the time for a point on the wave to undergo one complete oscillation. Okay, for example, I'm going to try to rerun. Okay, now I hope that you have noticed that this red dot oscillated up and down in position in here as the wave moved forward. And you notice the wavelength, like we talked before, is in this case represented through this blue curve, and which is actually the distance from a crest to another crest, to the next crest. It could have been from a trough to a trough, or any point of the wave to an identical point of the wave. But since it's easier to distinguish the crests here, the areas of maximum compression, we have it represented that way. The time for a point on the wave to undergo one complete oscillation is what we call the period. That's the time it takes, for example, this point on the string to move down and back up to the same point. That's what we call the period of the oscillation. The frequency, of course, will be the inverse of that. Concerning the speed of the wave, pay attention to the fact that the wave moves a wavelength every time the red dot is going to oscillate up and down once. In other words, the wave is going to move by an amount equal to the wavelength every period, which gives us the relationship that we talked about before, which is v equal to lambda over t, or lambda the wavelength, v times t, and that's a fundamental wave equation. It's applicable to all types of waves. Now, the speed of a wave, it depends on the properties of the medium. For example, for a wave on a string, it is equal to the square root of the tension of the string, the force that's pulling the string, over the mass per unit length. Mu is mass of the string over the length of the string. In other words, to get mu, you take the string, mass it, measure its length, divide the mass by the length. That's the way you get mu. For fluids, for example, a liquid or even air, it's going to be more the bulk modulus over the density of that fluid. So it's a modulus over the density.